All right, everyone. The learning portion of the lunch has begun. Woo. So we're going to be talking about feature toggles. Don't be so committal. It's a funny joke that Josh added. Sorry. So for the background, so before I give a definition of feature toggling, I'll just talk about some background software methodologies. So these are two strategies you can use to manage your source control. So the first one is feature branching, and this is when developers create a branch for each feature, and the branch is merged into the main branch when the feature is complete. So all the engineers here should be familiar with that. That's what we normally do. And the second strategy, some of you might not be as familiar with, is called continuous integration. And the idea here is that developers merge or integrate their code into the main branch at least once a day, and each merge is verified by an automated build. So there's a couple of problems with both of these approaches. Both of them have their own pros and cons. So for feature branching, you have the potential for severe merge conflicts, especially if your branch contains a big feature. So if you've been working on a feature that's taken like multiple weeks or maybe even a month to complete, when you finally merge that branch back into your main branch, you can have some big problems there. Should be said that modern kind of source control tools are pretty sophisticated nowadays. So most big merges that you'll run into are, even if they're big merges, you can normally fix them fairly easily, but sometimes it can be a problem. And for continuous integration, what happens if you have a feature that will take longer to implement than one day? So again, continuous integration has daily cycles. So each day, all the developers merge their code into the main branch, and that happens at least once a day. So ideally, if you have a big feature when you're using continuous integration, or I guess probably in any case, you want to break down your feature into smaller chunks. So ideally, with continuous integration, you can break down your feature into a small enough chunk that it can be completed within a day. But sometimes that's just not possible. For example, if you've got like an algorithm that's kind of central to your entire application, and it kind of has to be rewritten in entirety instead of just like half of it rewritten. It's kind of a binary thing. It's either working or it's not. In that case, if the algorithm is pretty wide-reaching throughout your application, you might run into a problem with continuous integration with this case. And so these are just some other general problems totally unrelated to feature branching or continuous integration. I want to implement A/B testing. I want to be able to disable certain features if our servers are under heavy load. And I want my app to have premium features that only paying customers can use. And the answer to all of your problems is feature toggling. So that's what we're going to be diving into here. So what is a feature toggle? A feature toggle is a binary condition that controls whether a feature appears in the app or not. So I'll just give a basic example here. So here we have a feature toggle that's controlling whether or not a hamburger menu is appearing in your app. So let's say you want your app to conform to Apple's user interface guidelines and you want to add a hamburger menu. I'm just kidding. But yeah, oosh. So in that case, if you want to add that in, you might want to add a feature toggle for that. And so here we have the code here. There's an if statement, and it's just referencing a configuration here, which dictates whether or not that hamburger menu should be added into the application. So if the Boolean value here is true, then in your running application, the hamburger menu feature will be added in. And if it's not, it won't be. And so the configuration file, the configuration, it can be just a static file that's kind of bundled with your app when you run it for the first time. That just has a list of Boolean values that indicate which features are on or off. It also could be a little more dynamic, like you could have reconfigurations during runtime. So for example, every time your app gets returns from the background, or you could have it even more dynamic and have configuration information being embedded in server responses to your application. It's kind of like a request by request update to configuration values. So I'm just going to talk about 4 categories of feature toggling. So there's release toggles, there's experiment toggles, there's operational toggles, and there's permission toggles as well. So we'll start with release toggles. So what release toggles do is they allow incomplete or untested code paths to be merged into your main branch. So I'll just use the same example I used before, the hamburger menu. So let's say you think that the hamburger menu is a big feature and you want to use a release toggle and start working on that feature, integrate it into your main branch, but have the power to basically turn off that feature so that none of your in-progress code is ever executed. You could use a release toggle for this case. And you might want to use this method for feature branching if you have large features or comprehensive refactoring. Think like that algorithm example I gave earlier. So in that case, for feature branching, you could take on kind of more of a continuous integration approach and start merging your feature into the main branch, and obviously having it turned off until that feature is complete. For continuous integration, you can use release toggles to fix the problem I mentioned earlier, where you have a feature that takes longer than a day to complete. So another category is experiment toggles. So this example here is using something called A/B testing. And if anyone's not familiar with what A/B testing is, it's basically releasing two versions of an application, one with feature set A, one with feature set B. And the purpose is to determine which version of the application is more effective. So for example, you could be testing wording in a call to action button. So you could have a certain wording for your A version of the application and like slightly different wording for the B version of the application. And what you want to do is you want to measure how effective each one is. So you might measure like how many clicks that button gets in version A versus version B, for example. So experiment toggles can be leveraged to make this easier. So what's going on here is just you've got basic if-else statement here that's referencing the config to test what group the user is in, and then it will display group A or it'll display app A or app B depending on which testing group that particular user is in. Yeah, another category here is operation toggles, and these just control operational aspects of the system. So an example of this is if you have a new feature and you're not really sure about the performance implications of that feature. For example, you're not sure if your servers can handle the load of this particular feature. What you can do is you can give yourself control over whether or not that feature is actually displayed in the application during runtime. And another category here is permission toggles. Let's say you have some premium content in your application that you only want paying users to be able to see. You can have a toggle for that as well, just to make sure that, obviously only the users that paid for this content can see that content. And this is an example of when you may want to use a more dynamic configuration approach. So for example, you could, when the user, say, hits the route on the server that verifies a payment of them like agreeing to or them paying to be a premium customer, the response can embed configuration information into the app so that the app can update its configuration logic so that it now displays this feature. So now it's time for the fun part with Josh. He's doing the implementation. I don't know, I thought my part was pretty fun too, but I'm sure maybe this will be more fun. Funner part? Okay.
So who here woke up today and thought, I'm going to have some fun today? Good. All right, everyone, nice. Well, this is, if you haven't had any fun yet, this is the first. Glad your wish has been fulfilled so far. Let's see where we can take it. So, smash. Okay, got that out of the way. So what you need to do for when you're doing you're implementing these feature toggles is you might have a big feature that you're going to do. Let's say that it's like a new. For example, flying car. You're going to implement. You have a car. You're going to add wings onto it and make it fly. So that's a pretty big feature. So you're going to want to start breaking all the toggles down into smaller pieces. So essentially at every decision point, you almost want a toggle for each decision point, and that will allow you to have much greater finer grained control over what you can turn on and off. So it's a good way of doing it. So here you can see that one feature is smashed into many toggles. So you start off with a nice big feature triangle here, and you just broke it down into smaller pieces. Has anyone here coded in JavaScript before? Okay, there's been few people. Good. I figured actually this is the common language that we used. I didn't want to be too opinionated. So this is before. I mean, basically it's just a simple if statement. You have your const features equals new features. Features is what's going to contain all your flags in terms of like, is this feature enabled? Right now we're just instantiating it. We'll get into other ways of instantiating it later on. Then you have this function avoid car crash. If the features is flying enabled, you want to avoid the car crash by flying. Otherwise, you're going to want to brake. So there's no particular problem with this, but the issue is that basically feature toggles have a way of becoming proliferating through your code. So it can be, so it's kind of, they become like an all or nothing thing. So you can just essentially, even though they're all essentially being turned on by the same thing, you can, what you do is you create you create more flags that all relate back to the main feature, and that way essentially you have the ability to turn them on and off individually, but at the very beginning they're all going to be turned on by just is flying enabled. So here we're adding a feature prototype is car crash avoidance flying enabled, so we're just enabling that one feature of avoiding the car crash by flying instead of just flying in general. And then here we're just returning whether flying is enabled. And then we have our function avoid car crash. And then we're just saying if features is car crash avoidance flying enabled, then we'll fly, else we're going to brake. So basically what I'm talking about right now is like how to basically do the bare implementation of the feature toggle. So one we smashing it up into smaller toggles. Then we're going to take those toggles and throw them into our objects. This is also known as
feature breakdown smash.
Right. It's also known as when you're taking, when instead of instantiating an object, you're injecting it into the object. What's it called? Dependency injection, yes, or inversion of control. Yeah, so basically imagine it like a basketball going onto a hoop. So yeah, toggles are thrown into your objects. So we got our fuel injected or feature injected. Yeah, so essentially to do dependency injection is pretty simple. You just either pass in the dependency in the constructor, usually, or you can use set methods, but usually we prefer constructors because the idea of object creation, object instantiation is initialization, so that way your objects are always properly initialized. So you're passing in your features object, and now it looks like autopilot.prototype.avoid car crash is equal to this function, and here we're just essentially calling that rather than creating it at the instantiating at the beginning like this, where we're creating a new features object, we're passing it into the constructor. So this is actually, if you aren't that familiar, this is one of the patterns for doing objects in JavaScript, where you base this function autopilot. That's actually how you declare an object in JavaScript, or one of the ways. And there. Now, so polymorphism is calling on the phone. You're going to pick it up and answer. So basically, the idea of removing conditionals. So imagine Yoda. He's teaching you a lesson. He's like, there is no if. There's only do, and do differently. So yeah, essentially the idea about removing conditionals is that you create simplified code. It's more object-oriented, and you basically use design patterns to get rid of the conditional. I mean, many of the things you're already familiar with, but they always come down to using polymorphism. So instead of having an if-else, you have one object that does one thing and another object that does something else, and you instantiate them usually in some kind of factory. If that was all gobbledygook or I spoke too quickly, here's an example in JavaScript to give you an idea as to what I mean by all that. So before we were passing in an object called features into autopilot, and then autopilot in avoid car crash was checking the if. So we have the constructor, we're passing in a crash avoider, so this dot crash avoider equals the crash avoider that was passed in. Then we avoid car crash. First we're going to turn down the music so we're not distracted. Then we're going to just call that avoid car crash method on that object that was passed in, the avoid car crash. And that is instantiated. Basically, this is using a strategy pattern. So here you have a flying avoidance strategy and a braking avoidance strategy. Now, a strategy pattern, if you aren't that familiar with it, it's just a way of encapsulating an algorithm in a class, and then you can have different implementations of that algorithm or what it actually does. Any questions about that? Okay, so essentially, yeah, we get rid of the if statement and avoid car crash. We're just using the so dependency injection and inversion of control. They're kind of complicated ideas for really just getting using a factory, some kind of factory method, so that some kind of factory pattern combined with some way of passing that created object into your classes. So you can either inject them using an injection framework, or you just pass them into the constructor. So for when you're configuring these, so that was basically like how to go about implementing them, and the configuration of the feature toggles. I heard a conversation earlier today about using a config file. That is definitely a good way of doing it. Usually, you got to ask the questions: is it okay to change the value of a feature toggle by redeploying? Because that makes your life a lot simpler. I'll get into that. Is it going to be a per user feature toggle? Like, is it going to be? Are we going to do A/B testing? I'll talk a bit more about that. At some point in time, you're gonna when you're using these a lot and you have a big system, you're going to want some kind of admin portal, where a system admin is going to be able to change these configurations. A very simple thing to do, which is good, is especially when you want to send out builds to beta testers, is to have an in-app screen that will allow you to turn them on and off. So if you have a generic way of creating the screen, it's not that difficult thing to do and adds a lot of value. So you basically have Project Coriander has this, where you can basically bring up a screen, you can turn on feature toggles on and off. And then where are you going to host the config? There's actually companies that do only this. They have a lot of infrastructure for hosting configuration files. Mostly, they're basically like large key value databases which allow quick responses. So this is the preferred configuration method when redeploying is fine. What does that mean? It means you're going to compile it in. It's going to be compiled. So when you, there's lots of reasons for preferring what's called static configuration. Mostly is to deal with simplicity, so you know exactly when a build goes out what is configured in it, and it's reproducible. So if people report a problem, you know what was in that build that they were testing. So for example, in Project Coriander, a lot of essentially the way it works is they have everything in their release build is turned off, and everything in their debug build is turned on. That's essentially what it is. And then they have a page that they can turn things on and off. And getting back to Dan's question, once something is turned on, then it goes out for that. Once something is turned on in release, means it's ready to go. The next release cycle, they remove it completely. So the feature toggle is removed completely. So so it's only ever on for one cycle, and then it's just deleted because it's assumed it's always going to be there. And then it allows them to turn it off. But you can do that. Those are with they kind of a simplistic implementation of feature toggles, but you can get obviously more sophisticated with A/B testing and experimental testing and so on. So yeah, I prefer static because it's just a lot simpler and you can redeploy. But for some things like A/B testing or experimental testing, also sometimes you want to do, one we would want to use is sometimes you want to be able to force an update to basically test that workflow. So that's always going to be there. You're always going to have this flag that says, should we force an app upgrade? See what that workflow looks like. So when people are going their own way, some ride sharing is going to be involved because there's going to be the same features are going out. You can use, there's a number of ways of doing it, but one interesting way is on every request, or on, say, the main request where you're getting your config, you add a header based either on the user context or on the, if you're doing A/B testing, based on some random number or their location, to turn it on, to turn a certain feature on. So it comes in on the request. You see, hey, this has a HTTP header coming in that we should turn that feature on and off. You can also, if something is failing in production, then you can turn it off as well using this method. You could also just do it with a simple config file that is retrieved from the network that you're getting anyway. That's actually how feature toggles usually start, is that in some kind of config that you already have. Yeah, there's something else, but yeah, it adds a bit of complexity. Yeah, going more to Dan's point, you don't want any wallflowers. Wallflowers are people that go to a party and they stand against the wall and they don't dance, and they're actually producing no value to the party. So they don't last very long. They're kicked out. You really want everyone at your party, you want dancing. So, and the reason why is because you want to keep, imagine all your feature toggles as inventory. Now, a lot of companies that deal with inventory know that you want to keep your inventory low. They even have just-in-time delivery. Some places where they actually don't have any inventory at all. So it's basically just a way of keeping your inventory low. One interesting example of not doing this that bankrupted a 400. So there was a securities company. It was a tragic story, actually. A securities company. It was an investment company that had, $400 million in assets, and they deploy went wrong. What happens is they were using essentially a toggle to turn this feature on. there was this old feature that was around for 8 years that they had they weren't using anymore. They haven't used it in 8 years, but it was still in the code base. They reused the flag because they didn't want to create a new one for some reason, and they I don't think a good reason. And then they tested it; it worked fine. They upgraded 7 of their 8 servers. The 8th one got the flag to say, "Oh yeah, turn on that old code that's been around for 8 years that no one's been using," and it's caused mayhem. And they basically sold all their stock in 45 minutes and lost $400 million in assets. So yeah, so keep your inventory low. Yeah, it was. Yeah, they had to file with the SEC, and the line was, if you have to file your deployment issue with the Securities Commission, it's not a good thing. It's probably a bad thing. All right, so I think we're okay. Everyone, just gently close your eyes. Okay, relax. Take a deep breath. Breathe right into the lower abdomen. Okay, now slowly open your eyes and stare at the circle. Notice that you're feeling more and more relaxed. Branches, be gone. No need for branches anymore. This is a brave new world. It's a bit hard to, it might feel like it's hard to accept, but yeah, it's a brave new world and there's some great things. So just leave your mind open, accept it. So what else? Oh yeah, so to summarize, this is our summary page, in case you were wondering. Smash to smaller pieces, inject to basically, and do differently. So those are just, yeah, just good software design in architecture. So you basically want, a lot of times people are just doing this with, I mean, a simple feature toggle is commenting out code and commenting it back in. So it's been around since ever, probably, since they first invented the comment. So yeah, it's just basically being more structured about how you're going about doing it, because it's all being done to a certain extent already in any application that's been around for over a year. These are going to be in there. It's just being more organized about how you're doing that. Use cement shoes, like just if you don't automatically make it configurable on the per route or whatever, because it adds some complexity as to so you're not exactly sure what's configured at a time. Toggle on request as needed, and yeah, don't keep wallflowers around. Thank you very much.